I believe we're about ready to start here. All right, I'd like to thank everybody for attending. This is the Post-Glover Resistors 2021 Winter Webinar Series. This is installment number 1, and this is on dynamic braking, things you didn't know you didn't know. And I want to remind everybody that on February 24th, we are going to have our second installment of the Winter Webinar Series. It's going to be on hybrid grounding. And then on March 24th, we're going to cover IEEE guidelines for resistance grounding. All right, my name is Steve Fisher. I am one of the Post-Glover application engineers / regional sales managers with the company. I graduated with a Bachelor of Science in Mechanical Engineering from the University of Notre Dame so many years ago, and I have been here at Post-Glover for over 15 years. All right, so let's talk about what we're going to cover today. The beginning of the seminar is going to be a quick review on dynamic braking resistors. And I also want to mention that I may just call it a dynamic brake. I may call it a DBR. I know on some of the slides it actually says DBR, so I just want you to know that DBR is a dynamic braking resistor. After that, we are going to discuss issues you may or may not have thought about when you're choosing your dynamic braking resistor. And I am going to stress throughout that airflow is important. And I also want to mention that during the presentation, if at any time you have a question over on the, well, it should be on the right side, you can type in a question and hit enter, and it will send off to one of my colleagues here. And your answer will come back in one of a few different ways. He can either reply to your answer, he'll type it in and hit reply, and you'll see your answer. If it's a question we think everybody might want to hear, we might discuss it afterward. After the presentation, we'll have a little question and answer. He'll read it off and we'll answer the question. Or if it's something that we think will take a lot of detail or more thought or some back and forth, we will do this by email for you and give you a more complete answer. Okay, so dynamic brakes, basically you have a dynamic brake is used in conjunction with your variable frequency drive. So when you have your variable frequency drive, you have AC current coming into the variable frequency drive. It takes that AC current and converts it into multiple DC current pulses. And what it does is it replicates a waveform just like your AC current does. And the reason that's done is you can take those little DC current pulses, and by actually varying the frequency of those, the output to the motor will be different. So then you can either slow down your motor or speed it up as needed. So while this is happening, your motor is running, that variable frequency drive is giving energy to your load. However, when your load stops or slows down, all that energy is going back to the variable frequency drive. Now, if it's a fan or something to that effect, where you just turn it off and it slowly winds down, it's putting very little energy back to the drive, and the variable frequency drive can handle it. It doesn't bother it. However, if you have a sudden stopping, or if you have a very large load, or if you're jogging or something like that, it's putting much more energy back to the variable frequency drive, and it can't handle it. So what it'll do is it'll trip on over voltage. So what actually happens is there's a part of a variable frequency drive, or sometimes it's a separate unit called the breaker chopper module. It looks at the voltage that is building up on the capacitor, and when it reaches a certain point, it decides to take all that energy and dump it all onto this resistor, which is the dynamic braking resistor. So as it's shown here. So then the resistor takes all that energy, it drains that capacitor, and it turns that energy into heat. All right, so some basics on dynamic braking resistors. The benefits are that they are very simple and low cost. As I discussed, you're just wiring up to the DC circuit on the drive. You have a DC positive and a DC negative. You can hook it up. There's a terminal block Typically on the dynamic braking resistor, you hook it up on either lead. Doesn't matter if it's backward, and it's that simple to install. And what that dynamic braking resistor does, as I just discussed, is it safely controls and stops your load, allows you to safely control and stop your loads. It removes energy from that drive and turns it into heat. So since you're taking that energy and turning it into heat, you have to think about that heat. There's energy lost, so you have to make sure what's around it is not going to be affected by the heat. And you also have to think about the overheating concern, not only the environment, but you have to, if it's a very large load, you might want to restore the energy somehow with a regeneration instead of burning it off. You also have to think about cooling these off correctly and sizing them correctly. And we'll talk about that in a second. And also sometimes people always account for where they're going to put the variable frequency drive. Sometimes they don't think about where to put the dynamic braking resistor. So try to think of that ahead of time. Usually they're a lot smaller, but they do have to be placed somewhere. All right, so dynamic brakes are usually sized by an ohm value and a watt value. So we have to discuss about why are the ohms and the watts important. As you can see here in this picture, there are two pictures of two different dynamic braking resistors. One is for a very small horsepower drive, and one is for a very large horsepower drive. I think it's kind of obvious which one is which here. So the one that is for a smaller horsepower drive is going to be a lower wattage resistor, and typically the lower wattage resistors, like the one on the left, have a higher ohm value. The resistor that looks like the one on the right is going to be for a larger horsepower drive, and typically the larger wattage resistors have a lower ohm value, and we'll talk about that in a second too. So your resistors, when you're trying to choose your resistor, you have to choose your ohms and your watts. So when you're choosing your ohms, there is a minimum resistance and there's a maximum resistance, and the resistance that you choose has to be between those two in that band of minimum and maximum. I will say your smaller drives, like a 5 horsepower drive, they have a very, very large band you can choose from. So for instance, it'll be anywhere between the minimum ohms, which is 100, and the maximum will be 1,000. And if you have a larger horsepower drive, it's going to be a much smaller band. It might be between, say, 2 and 2.5 ohms or something to that effect. So the minimum resistance is determined by the variable frequency drive manufacturer. Usually you can find it in the catalog or in the brochures. It'll tell you what your minimum ohm value will be. And that ohm value is determined by actually the current that can run through the transistor that's in that drive. And if your ohms are too low or below that minimum, what happens is you have too much current running at once and your drive will trip on overcurrent. Okay, so there's also a maximum resistance value, as I spoke about. That value is actually calculated, and it's based on things like your horsepower, your bus voltage, your braking torque, your stop time. There's a couple of motor efficiency, there's a couple other things, but that's a calculated number. And if your ohms go above that number, your drive may trip on over voltage. So summary, if your ohms are too low, you're going to trip on overcurrent. If your ohms are too high, you're going to trip on over voltage. So there may be times when your actual minimum ohms is less than or equal to your maximum ohms, in which case you may have a problem. Now, if your minimum and your maximum are exactly the same, something you have to think about is you may start out, say for instance, your minimum and maximum of 20 ohms. If you start out with a 20 ohm resistor, as you have current running through that resistor, that element is going to heat up. And as any conductor heats up, the resistance increases. So you may start out with a 20 ohm resistor, but by the time your cycle is done, it may end up being, say, a 22 or 23 ohm resistor. So you might go over your maximum and you might trip. So think about that as these heat up, that the resistance will increase slightly. So the minimum and maximum overlapping or being equal is likely to more happen if your braking torque is very high on your stopping. And it's usually only happens on your larger horsepower units. As I stated before, when you have a smaller horsepower, your band is really huge. So if you have this issue, there are a few things you can do. You can choose a different variable frequency drive that has a lower minimum ohm value. So when I say that, you can either say, for instance, if you have an application with a 50 horsepower drive, you could either step up to a 60 or 75 horsepower drive. They will typically have a lower minimum ohm value. So that will allow you to brake safely. Sometimes it's the same frame, the actual minimum ohms might be the same, but you have to look into that. You can also, if you like to stay with one manufacturer, you can use a different series of drive from that same manufacturer. If they have a Series A that is 10 years old and Series B, which is relatively new, only 2 years old, if you're choosing one, the other one might have it will have a different minimum ohm value, but it might be lower than the one you're looking at. And if that doesn't work, you can always choose a totally different manufacturer of variable frequency drive. They all have different minimum ohm values. If you already have your drive already chosen and purchased and installed, what you can also do is you can purchase an external chopper or transistor. What that will do is your drive usually has an internal braking chopper, and if you replace it with an external one, that will override it. So you can buy an external one that has a lower minimum ohm value. Again, you can get, if your minimum ohms are 20, you can buy a chopper that has a ohm value of minimum ohm of like 10 or 15, and then you're good to go. If everything is close, there are settings you can choose on your variable frequency drive to allow you to tweak those a little bit. You can start it a little earlier, and let's say you're tripping after 5 seconds of duty and you want it to go 6. Sometimes you can make some adjustments if things are close. And also, if your maximum is about equal to your minimum, and if you have a very low braking torque, that maximum is calculated with a 100% braking torque, or if the torque is higher, then the calculation is different. If you only need like 60% braking torque or something of that effect, you should be fine, because your maximum you can probably go above your maximum and not trip. Okay, so choosing your wattage. So one thing you have to remember is that you always want to make sure that the wattage of the dynamic braking resistor that you purchase is greater than or equal to the wattage that you calculate that you need. So again, don't undersize your wattage on your dynamic braking resistor. If you have more than the minimum wattage required, you're safe. What it does, it gives you additional quote unquote headroom, and it increases your safety. So in other words, your wattage is based on your resistance, and it's also based on your current, because power equals I squared R. So if you buy a larger wattage, that means the resistor that you purchase can handle more current. So what that does then is, if it can handle more current, the resistor coils will actually run cooler, and it will also allow you for increased duty in your future. Let's say you have a load with a large inertial load, you want to stop, and it takes 20 seconds. Well, you buy your resistor according to that. But if you buy something with more wattage and you want to increase your load later on, and it takes 25 seconds to stop, by purchasing that larger resistor, the larger wattage resistor, it allows you for that duty increase in the future. One thing to think about though, if you do that, is it may potentially cost a little bit more money and be a little bit bigger in height or footprint. Again, it depends on if you're going to the next frame size of resistor or not. You see in the background there, you have a picture of that toaster. I'm going to revert back to this picture in a little bit. But you see that the toaster is basically a resistor wires running through that circuit. And we all know that the toaster gets really hot. It gets red glowing hot, and that's done purposely so that your bread turns into toast. Red hot coils are good for a toaster. They are not good for your resistor. So we'll go back to that. Again, you got 5 amps running through there. Very thin coils. If I put that same 5 amps across a 500 kc mil cable, you're not going to have any heat, right? So you've got more mass there. It's not going to heat up those coils. So we'll talk about that a little bit later. But if you do not have enough wattage in your dynamic braking resistor, you are going to have this issue with it getting red hot, and you could have personnel injury, because they'll be walking close to the resistor or touching it. The resistors will have a reduced life when you're overheating this way. And I will mention that most of your dynamic braking resistors should have a thermal switch shipped with them. And if you wire that up to your enable circuit in your variable frequency drive and your overheating resistor, the thermal switch should change state and your drive will trip. So you're going to have potentially nuisance tripping on your variable frequency drive because you didn't buy quite enough wattage on your resistor. Okay, so when you do get your resistor or you're picking out your resistor, you need to verify that the resistor that you need for your application. So when you go and pick out your drive, you can go in that drive manufacturer's catalog or their application guide or whatever they have. They will a lot of times give you a suggestion of what dynamic braking resistor you should use. One thing you have to think about is, for instance, that manual might say for emergency stopping, use this resistor. But there is no standardization for what quote unquote emergency stopping is, right? One manufacturer might assume it's 5% duty, another might say 10% duty. You might actually be emergency stopping, but again, if you have that high inertial load, it might take you 20 seconds to stop. So if it takes you 20 seconds to stop this huge load, that's not emergency stopping. That is more like a light duty or a medium duty type application. So, you know, don't get tricked by the words. You have to think about what the actual duty cycle is on these. So look into it maybe and see what they mean by these. For instance, heavy duty on one manufacturer might mean 40% overhauling, and for another manufacturer, he might assume it's 50% overhauling with a braking circuit afterwards. So make sure that what you're getting is what you need and what you want, because if you don't, you could have nuisance tripping going on, and then that will lead to failures. So what is actually needed to design your dynamic braking resistor? Typically, you just give the ohms and the watts, and your manufacturer of your dynamic braking resistor will ship you the same ohms and watts that you asked for. A lot of times, though, you don't know those answers. So you can give the horsepower, the voltage going into the drive, and the duty cycle, which means how often is it going on and for how long, and also if it's overhauling type load or a braking type load. So by giving those three things, you can typically figure out what your duty is and what horsepower, what ohms and watts you need. Again, if you don't know what your duty cycle is exactly, you can describe your application. You can talk to your drive specialist or the manufacturer, describe your application, talk about what's going on, and then they can help you figure out exactly what wattage you need and ohms you need for your application. Okay, so now we have our first poll question.
So the answer to our first poll question overwhelmingly has been a yes. That most people did in fact attend the first dynamic braking webinar. And I believe they're mainly just checking you at this point, Steve, to make sure you know what you're talking about for a full 2 hours.
So it's basically, the 2 hours is basically the extent of all my knowledge after 50 years of experience, and then I'll be done after that. So, okay, so let's talk about installation concerns. So there are main topics. You have to think about the actual physical environment of where your dynamic braking resistor will go. And again, I'm going to get into more details on all this. And you have to think about where it's going also. So there might be dimensional constraints. It might be something, you might have an I-beam going across there, so you can't have something that's too tall, or you might have a footprint issue where it can't be too wide and tall is fine because you have a ceiling that's 500 feet high. There might be other equipment around you. So these are things you have to think about. And again, we're going to go into more detail on these here. So the first thing you have to think about is your environmental considerations. I'm going to have, again, a slide on each one of these bullets here. So think about, are you going to be indoor or outdoors? Because they're going to have different enclosures accordingly. You have to think about your atmosphere. Is it a dirty atmosphere? Are you in a potash plant? Are you in a steel mill? Is it clean air? Is everything pristine? Your ambient temperature you have to think about also. Again, if you're in a, way up in the risers in a steel mill, it's going to be very hot up there. If you're somewhere else, it might be colder. So think about your ambient temperature. There's sometimes a caustic environment. If you're in a chemical plant or if you're near the ocean, you have a lot of salt in the air. If you're in a hazardous area, you have to think about that. And there's sometimes also a wash down or a hose down duty that happens. Like if you're in a food plant or in a automotive plant, for instance, sometimes they hose down things at the end of the day or wash them down. Okay, so the indoor and outdoor. NEMA has standardized, they're in enclosures. There's a NEMA, the most common for dynamic braking resistors and for a lot of electrical equipment is NEMA 1, which is indoor, and NEMA 3R, which is outdoor. Okay, so if you see here on the left, this is our standard NEMA 1 indoor style enclosure. And you can see there is a lot of airflow allowed to come out of that resistor enclosure. The NEMA 1 is basically telling you can't touch any of the electrical equipment inside there with something larger than a certain diameter size. And you can see that, again, there's lots of grading all around there. And the reason for that is because resistors, as you probably know, create a lot of heat. So that heat that's created by the resistor goes into the air, and then the hot air will rise out of the resistor. So the enclosure top is open, and as the hot air goes out, it has to be replaced by cool air, which comes in through the sides. So that's the best application there, is a NEMA 1 allows the resistors to breathe a lot. Over here on the right, we show a NEMA 3R, which is outdoor, and R stands for rain. So if it's raining, your resistors will not see any rain. And a standard NEMA 3R doesn't have this bottom section on it. It's just this louvered section with this top. Sometimes you want more airflow, so we include this bottom to allow more air to come in there, because these louvers won't quite let in quite as much air as the open bottom wheel hill are on this NEMA 1. However, you see there's a lid on there. But as you can tell, that lid is not just placed right on top of that standard enclosure. You have standoffs here to allow the air to go out the top, and then what it'll do is it'll billow out the sides. So it goes out the top, billows out the sides, because that roof is raised above a little bit. There are times when people will ask for a NEMA 4X dynamic braking resistor. That is not something that's typically done. It could be done, but the enclosure would be gigantically huge because all that heat that's created by those resistors. The NEMA 4 part of NEMA 4X actually means it's NEMA 4, which is there's no ingress, which means you're going to be trapping all that heat. So the X part of it means it is usually stainless steel. So if you're in a bad environment, it won't rust. So what we offer typically, or what any dynamic braking resistor company offers, is a NEMA 3RX. You get a NEMA 3R enclosure such as this, and you make it out of stainless steel, so it doesn't corrode. All right, so you also have to think about your atmosphere. Think about the air quality where you are. There might be airborne debris. Let's say if there's a lot of dust, again, steel plant, something like that, paper plant, there's dust in the air falling. You don't want that going onto your resistor elements. Or if you're grinding things near it and there's metal shavings flying everywhere, you're going to want to put a lid on top of this resistor. So you can use a standard NEMA 3R, which is fine. Sometimes you need extra airflow, so you want to use the NEMA 3R with the bottom. But if that gets to be too tall, you can take a standard NEMA 1 and put a top on it. But again, you have to make sure that you have those spacers to make sure the lid is above the top of the standard enclosure so that the air can go out of the enclosure and then go out the sides. Again, this will maintain your adequate airflow that's needed to cool off the resistors, and it will keep the debris from actually hitting the coils. All right, another factor to think about is your ambient temperature. As I've said before, and I'm going to say it again, is the resistors do generate a considerable amount of heat. So the actual wattage that we calculate on the dynamic braking resistor is, let's see, wattage is equal to I squared R. So the resistance, say, is a 20 ohm resistor. It's somewhat fixed. So the I squared means how much current can I run through that resistor to get a certain amount of wattage. So as that current goes through there, it heats up the element, as I said before. So if you're in an ambient temperature, if you have the exact same application, say, for instance, again, I'm going to go back to the steel mill. If you have a steel mill down in the deep south in July, and you have that same application way up at Santa's workshop in January, up in the North Pole. So the resistor elements down in the deep south in the middle of the summer are going to be a whole lot hotter to start with than the ones that are up at the North Pole. So what happens is you're starting out at a higher temperature. So I want to run that current through that resistor. I calculate the wattage when that resistor element hits a certain temperature. But if you're starting at a higher temperature, I can't put as much wattage, I'm sorry, I can't put as much current through there when it reaches that given temperature. So what I actually have to do is for the resistor that's down south at that heat and that very hot ambient temperature, I have to oversize or I have to add more mass to that resistor to allow you to run more current through there. Again, think of that toaster I showed you before. If you have really thin coils there, you've got a lot of current running through there, it's going to get hotter. If it starts out hot to start with, it's going to get even hotter yet. If I add more mass, for instance, like a 500 kc mil cable, it's going to run a whole lot cooler. So if you start with a higher ambient temperature, we're going to give you a little bit more mass on your resistor element to allow it to run a little bit cooler, basically. You also have to think about this if you're in high altitude, because at higher altitudes you have thinner and less conductive air. So you might have to derate your resistor a little bit too. If you have a high altitude, just let them know what the altitude is, and whoever's doing this calculation for the wattage will take that into consideration. It may not be any different, but it may be. So you also have to determine whether you have a bad atmosphere, a caustic atmosphere. There might be times when you have a salty or a corrosive atmosphere. And when I say salty or corrosive atmosphere, I'm not talking about when you're around your teenage children. I'm talking about if you're near the ocean or if you're in a chemical plant or something of that effect. You're going to have to think about your enclosure. It might rust more if you're around a lot of salt. So in those instances, you can have a different type of enclosure. You can either have it painted, which will add a layer of protection, or you can actually get a stainless steel enclosure, which will last longer. There are different types of stainless steel enclosures. You can get for instance, a 304 or a 316 stainless steel or whatever. But there's different grades of stainless steel, but depending on how bad your atmosphere is. One also thing to mention is if you have a larger dynamic braking resistor, sometimes the actual elements that the resistor is made from, typically it's a special alloy of a blend of stainless steel with other elements added to it. And what that does is it allows the resistance to not increase very much when you run that current through there, because as I stated before, when you run current, things get hotter, and as they get hotter, the resistance increases. So most resistors are made with a special blend, so the resistance doesn't go up too much. But if you're in a caustic environment, you can use, for instance, a 316 stainless steel element so that those don't corrode. But you have to think about is that the resistance will increase more. So if you start off again with that 20 ohm resistor, it might go up to 22 or 23 ohms with the standard element. If you're using a 316 stainless steel element, it might jump up to 28 or 29 ohms. Or again, we can calculate all that, but you have to think about that. So if your minimum is 20 and your maximum is 25, you're okay with the standard element. You may not be okay if you use a 316 element. So that's something you have to take in consideration if you do want a non-caustic element, not just the enclosure. So there's also, it's very rare, but there are times where a dynamic braking resistor could be put in a hazardous area. Again, you don't see it very often, but if it is the case, you're going to need the T code rating, or what's called the auto ignition temperature, or AIT, of the gas that's in that air. So for instance, if you're at some chemical plant and there's a certain gas in the air and it will ignite at 150 degrees C, you want to make sure that your dynamic braking resistor is designed so that the temperature does not rise above, say, 120 degrees C or so. Again, that can all be calculated. But what we just do is add more mass to the resistor. It allows the resistor to run cooler so that when it is energized, it doesn't get as hot and it doesn't cause a scene, as you can see on the bottom there. So there's also times when you have wash down or hose down duty applications. This is typical for sometimes a food plant or a bakery or something to that effect. Sometimes automotive plants have this. There's a aluminum case style resistor here shown on the top. Those are rated at IP65. How this is done is there's an aluminum extrusion, and you cut it to length depending on how much wattage you want inside that resistor case. You actually put a potting in the bottom, you bake it, you let it cure for a day, then you put the resistor inside the aluminum case. You have the wires coming out, you put more potting in there, you bake it, you let it cure for a day. So now you have a totally sealed a totally sealed dynamic braking resistor with elements inside where they won't be able to see the water or heavy dust or whatever it is that's in that environment. These little dynamic braking resistors are sometimes often used for panel mounting. One thing I would say is obviously you can see that it's very small and you can't get a large wattage rating for these. For instance, if you have a 500 horsepower motor, you can't be using these. If you are installing this somewhere and you have to install it vertically, make sure that these wires coming out of here are pointing downward and not upward, because if you are in a place where these are going to get wet, if these wires are pointing upward, the water will hit the wires, gravity will pull the water down, they'll track down the wires, they'll be sitting on this potted material, and eventually it may leak through or leach through from the heat inside there. It'll wick in there. So you want to make sure that these wires are pointing down so you don't have that issue. You also have to realize that there is no thermal switch with these. You can add one separately if you want, but typically it's not done. So you have to make sure that you size these correctly or above what you need to make sure they don't overheat. There are times when you actually want a hose down duty, and in those cases, what is typically done is you can take these IP65 resistors, put it in the style of enclosure, which is made out of stainless steel. So if you're hosing it down, none of the jet water actually hits any of the potting or the wires, the wire connections or anything. All the connections are made in this IP66 rated box down here. Okay, so we're ready for our next poll question.
And the results from our second poll question: what drive manufacturer do you typically use? Rockwell, followed by other, and almost a dead heat between the other three, ABB, Schneider, and Siemens.
Okay, so moving along here, there are location considerations to be made also. So wherever you put these, you want to make sure there's sufficient cooling available for your resistor. If you look at this picture here, there's just all kinds of stuff going on. There's different, you've got hot environments, you've got it up high, there might be a spot where there's not availability. So you have to think about what equipment you're putting it near or on top of, possibly. There might be size constraints. Usually when you order a dynamic braking resistor, you can easily get the drawing of the enclosure so you can know where it's going. You can make sure it'll fit wherever you're going. You have to think about access also. So you might be able to fit it somewhere, but you have to have access to that resistor later on or during installation. There's also orientation of the resistor, how it's mounted. We'll talk about that also. And there's times when there's going to be excessive vibration. You might want to bring that up because there are different styles of resistors that can be made. Okay, as I've said before, DB resistors do radiate heat. So because of that, you have to think about where you're actually putting this. Think about other things that are going to be next to it or close to it, because that heat might affect whatever is sitting next to it or above it. Not only do you have to think about the heat, but also consider how much wattage is going out and then the duty cycle. So for instance, if you have a 1,000-watt resistor and it goes off for 2 seconds once a day, that's a little bit of heat coming out. It's probably not going to affect too many things near it. However, if you have that same resistor, but it's going off, every 20 seconds all day long, you're going to have a whole lot more heat. So think about that. Again, airflow is very important for this, for the cooling. You have to make sure that there's enough space between the resistor and things around it so that the air can actually get into the enclosure and also escape out of the top of the enclosure. And another thing to think about is if you're putting this resistor in a climate-controlled environment, you have to think about your air conditioning. If it's a new installation, think about how often the resistor is going off and how much wattage it's putting out. So you may have to increase the size of your air conditioning unit, or if you already have your air conditioning unit chosen, it's already installed, it may stress it out, and it might be in the middle of the summer, the coolest you can get your room is 72 degrees because that resistor is always going off. So you might want to think about putting that resistor elsewhere. Okay, so there's also location considerations to be made. A lot of times the dynamic braking resistors are placed on top of or on the side of wherever the drive is. And a lot of times it's in a different room, but whenever you order your dynamic braking resistor, it typically will come with installation instructions. It'll tell you clearances you have to have around them for airflow or for maintenance. And so you should look at those before you install your dynamic braking resistors. And you have to think about things that are going to be around it. So for instance, if we look at this picture, let's say, for instance, these are all drives, and these are all the dynamic braking resistors on top of those drives. Well, if this dynamic braking resistor goes off, say once for a couple seconds, once a day, it's going to release a little bit of heat, but it's not a big deal. But let's say all of these are dynamic braking resistors, and they're all going off simultaneously for about 20 seconds, and they do it every 3 minutes. So that's a whole lot of heat coming out of these things. Well, if you'll notice here, there's a cable tray above here. So all that heat coming out of all these resistors all day long, after a while, what's going to happen is the insulation around that cable is going to degrade. And then after a year or so, you may end up getting ground faults occasionally throughout your plant. And again, that's going to happen because of the cable insulation. So be mindful of what you'll be putting above here. Again, you don't want anything plastic going up there either, something that could melt. So think about that, how often things are going off and how the heat's going to affect whatever is going to be around it. Let's say, for instance, you have this drive. This is a drive here. It's a smaller drive, so it's going to have a very small dynamic braking resistor. You could put it on top here, but you have all these conduits coming out here. So you might think, well, I'll just hang it on the side of this enclosure. Again, that's fine. It can be done, but you have to think about if someone's walking around that corner. If the dynamic braking resistor is a different size, might be hidden. You might walk around there and hit your head on it. Again, that's going to create heat. You don't want anyone to be able to touch that resistor. So just make sure that you have clearances around there or safety issues. Sometimes you can put the resistor up high if it's smaller, which is fine, but you also have to think about that resistor is giving off heat, and the mounting surface this on the side of this enclosure is going to get hot. So whatever's in this bucket here might be affected by that heat. So think about that too. All right, so think about the size of this dynamic braking resistor and also the access to it. So in general, the larger your wattage is, the larger the volume of your enclosure is going to have to be, because you're going to need more resistance coils in there. So that being the case, footprint is not always the only concern. You're going to have a bigger footprint the more wattage you have, but you might have a footprint issue. So what you can sometimes do is get an enclosure that's taller with the same footprint, but make it taller. So again, one's got to grow. As the wattage grows, either the footprint has to get bigger or the height has to get bigger. You know, the volume just has to increase. And there's going to be times where you can get one or the other. But let's say you can fit your actual resistor in this space that you have available. You do have to think about the maintenance and the cabling. So you can put that resistor there. Again, you can get the drawings of it beforehand. You can know where you're going to bring your cables in or your wires. It's typically through a knockout, or sometimes the big resistor will go through a hub in the bottom. But think about where your cable's coming from, right? So make sure that the orientation of that resistor, if it's long and not very deep but very wide, make sure the orientation is right so they can bring your cables into it. And also, most resistors will have, if it's smaller, typically the top will come off for maintenance later on. Let's say every year you want to make sure all your connections are tightened, so you have to do maintenance. So think about, you know, does the top come off? And if it's a bigger one, usually the front will come off. So you have to get at that for maintenance later on. And again, there's that old adage, you know, the 10 pounds of stuff fitting it in a 5-pound bag, you know. So, you know, if you need, you know, a 10,000 watt resistor, you got to have enough room for it, right? You can't put a 5,000 watt, you can't get 10,000 watt resistor in a enclosure that's only made for 5,000 watts. Okay, and as you get larger in wattage, of course, the enclosure's got to get bigger. So when you get to a certain size, typically they are floor mounted because you don't want to be mounting them or hanging them on things because they're going to weigh a whole lot more. So these floor mounted units, here's just a picture of one. You can see there's grating at the top here where all the hot air is going to go out of the enclosure. Typically, you're going to have a floor mounted one and they're going to be on feet. And the reason for those feet is because underneath here, there's grating also. The air coming in on these louvers is not enough airflow to allow the resistor to cool off correctly. So the bottom is usually grated. So that's why they have a feet. It lifts it off the ground. The air will come out from underneath, go up through the bottom, cross the resistor coils, and the hot air will go out the top. You can get these without feet sometimes, but if that is the case and you have a grating on the bottom, make sure you're putting them on I-beams or something so that there is adequate airflow coming in from the bottom. The other thing you have to think about when you're floor mounting these is there's going to be people walking around them possibly. And again, these enclosures may get hot. Make sure it's either in an area or has signs on it, or you know, there's a little, you know, caution hot on this one here. Make sure people are not going to be able to get to it and hurt themselves. This one shown right here is like around 30 kW. There might be times when you want, again, these are going to get really big. The bigger they get in kW, like for instance, a 500 horsepower motor, you're going to have a gigantic resistor. Sometimes you don't have the floor space for that, or you don't want to take up that floor space. When that's the case, what you can do sometimes is use a fan-cooled unit. You can put a fan on these. Here's a picture of, this was one of those units that took around 30 kW. It's bussed together with this other one that's 30 kW. So this is a 60 kW unit. The customer did not have, the customer actually wanted around 200 kW. Didn't have enough room. So think about 3 of these double wide enclosures going together to make 200 kW. That took up way too much space. So what you can do is you can put a fan underneath this. And by putting a fan underneath it, what that does is it takes the heat away from those coils. Again, the wattage is based on the resistance, which is fixed, and the amount of current running through there. It's I squared R. So as the current runs through there, it heats up those resistor coils. If you put a fan underneath there and you take the air off of that coil, you can allow more current to run through there. You can increase your wattage. You think about when you're eating a bowl of your grandmother's favorite hot soup. You put it on your spoon, you pull it out. Soup's too hot, so what you do is you blow on it, right? You blow on it, it cools off that soup. That's what that fan is doing. It's cooling off those resistor coils so that as the current's running through there, it's cooler. You can now run more current through there and increase your wattage. Something you do have to think about though is you can't just put any old fan on there, because if you just put a fan, say a smaller fan through the middle, you'll cool off the coils in the middle and the ones on the edges will still be very hot. You might overheat. So most resistor manufacturers will run tests on these type of things and make sure that the airflow is turbulent enough to cool off all the coils. And typically you can get 2 to 3 times as much wattage out of this. In this instance, we got more than 3 times the wattage out of this. And the actual enclosure footprint didn't increase, and the height increased by about 50%. So you have to think about also though that you have to bring 3-phase power to this, obviously, for the fan to run. Okay, so there's another location consideration you have to make is actually the orientation of this dynamic braking resistor. So you can see here on the top, here's another standard NEMA 1 type of enclosure for indoor applications. And the best way to mount these is, as it is shown here, is flat and horizontal. And the reason for that is again, these resistors creating heat. The heat radiates into the air, the hot air rises. You want the hot air to rise out the top. So the more area you have for that heat to escape out of that enclosure, the better. So this is the most optimal way. If you have to mount it on the side of another enclosure, the best thing to do is to make an L bracket to keep it this way. If it sticks out too far and you have to mount it flat, the best thing to do is to put this side pointing upward. Again, it's not quite as optimal because you don't have as much area for the air to escape. However, that's more area than if you have this top coming out. So again, this is the best to have pointing upward. This is the second best way to have it pointing upward. If you absolutely have to put it vertically mounted, make sure you do not point it, have it shown as is shown on the bottom here. Reasons for that is, again, these resistors are creating heat. That hot air is going to want to rise. If it's rising, it can't go out anywhere because there is a baffle here or a plate. So all that hot air is going to just sit on that plate. And these wires coming from the resistor to the terminal block are just going to see all that heat. You're going to break down that insulation. It's going to create those wires. Those wires will probably eventually fail. The other thing is you have the thermal switch is typically here. The thermal switch is seeing all that heat that's just sitting there, and your variable frequency drive may trip on the enable circuit from that thermal switch opening up. So if you absolutely have to mount it vertically, you want to mount it, flip it 180 degrees from this so that these are on the bottom, and this portion here is actually going to be this part where it's open and the air can flow out. There may be times when you're going to have excess vibration. An example of this would be like up on a crane. It's always moving, punting up and down. It's going to be trolleying, stopping. There's punches, of course. They are pounding all the time. It's going to vibrate if whatever's near it. So if this is the case, you should bring this up. There are different styles of resistors that are a little bit better for vibration. This resistor shown up here at the top is very common for a dynamic braking resistor for 10,000 watts and below, typically. These are just edge wound style coil, and they're just placed in these, what you can see these little teeth between here. They're not in there tight, they're just loose. So if there's a lot of vibrating and pounding going on, the actual coils there are going to go vibrating back and forth. They're going to keep hitting the teeth to the left and right of them, and eventually you're going to fatigue those teeth, and then they'll break off and you'll have issues. So again, just bring up if it's an excessive vibration. The design might end up being a grid style design. This is just one style of grid that's manufactured. There are other styles, but they're typically a little bit better for vibration type situations. So again, just describe your circumstance when you're talking about the resistor that you want. There are times when you want to repurpose your existing dynamic braking resistor. So something to think about, for instance, if you have an application and it's 20 years old and your 5 horsepower drive or your 5 horsepower motor end up failing just because either it's old or maybe you're stressing these so you want to jump up to a 7.5 horsepower. Sometimes you have the motor and the drive in stock. It takes a couple of days for the resistor to get there. So in the meantime, you want to continue running your whatever you're doing, making your product or whatever. So you can install that motor and that drive, and sometimes you can use that old resistor and repurpose it until the new one comes. Something you do have to think about though is you have to make sure that the resistance and the wattage that you need are what was there. Even if you're taking that 5 horsepower drive and motor and replacing it with another 5 horsepower drive, that brand new 5 horsepower drive might have a different minimum ohm value. So let's say, for instance, your old drive had a minimum ohm value of 20 and it had a 22 ohm resistor in there. Well, everything was fine. But if your new drive has a minimum ohm value of 25, you're going to install it. You're thinking, well, it's still a 5 horsepower drive. Everything will be fine. But again, your resistor ohms are going to be 22, and you might trip your drive until that new resistor comes. So you have to think about that. There are times when you might say, for instance, you're using that 5 horsepower drive and you're replacing it with a 7.5 horsepower motor and drive because the situation you had was stressing out your 5. So again, you can use that resistor sometimes for a short time. It may overheat a little bit because it was probably designed for a 5 horsepower application and now you have a 7.5 horsepower. But if it's used for a short time until the new one comes, again, the resistor might get a little hot. It's going to get hotter than normal, but it will last for a short time. And so at least you can keep yourself running and going until the new until the new dynamic braking resistor arrives. Just again, verify that the resistance is within your minimum and maximum range, and that the wattage is kind of what you need. All right, and one thing I do want to point out, when I was talking about wattage, not all watts are created equally. Well, you're going to think to yourself, well, a watt is a watt. Well, yes, it is. However, when the wattage is determined on a dynamic braking resistor, or basically any resistor element, as I said before, the wattage is calculated by the current and the resistance. Okay, so I can take, and as that resistance runs through that resistor element, as the current runs through that resistor element, as I said before, that resistor element is heating up. Okay, so as I put more current through there, that resistor element heats up to a certain temperature. So most manufacturers say, okay, I'm going to pick a temperature, and this is the temperature I'm going to stop my current at, and that's the rating I'm going to give it. Unfortunately, there is no governing body that says what that temperature has to be. One manufacturer might say, well, I'm going to let that thing run to 500 degrees C and then call it and see what the current is, and then that's the wattage rating. Another manufacturer might say, I'm going to let it run to 1,000 degrees C. It's right before it melts, but it's okay. It'll be all right. So, you know, the wattage rating, if you have two exact same dynamic braking resistors, one manufacturer might say 500 watts, one might say 1,000 watts. Again, it's not going to be that much different, but I'm just trying to drive home the point here. The only difference between those two is that the one is allowed to have more current run through it, and it's allowed to get a lot hotter. You can actually take both those resistors; they're probably going to be exactly the same. And just be careful. If you look at them and they're about the same size, they're probably about the same wattage, regardless of what the label might say on it. Again, if you go to a grocery store and you see a 10-pound bag of flour, it's going to be a certain size. If you see one a little bit smaller next to it and it says 10 pounds also, you're going to be a little bit skeptical. But you should do the same thing with your dynamic braking resistor. If one's a lot bigger than the other one and they're at the same rating, you should be a little skeptical. So again, just think about those things. There's also some times when dynamic braking resistors will have a duty cycle built into it. So again, you might have a 500 watt resistor. One might be 500 watts and one might say 1,000 watts for 50% duty. So again, they're going to be the same resistor, just that the one that says 1,000 watts, you're not supposed to run all the time. Whereas the one that says 500 watts, it will handle 500 watts continuously. So look at that also possibly. Okay, I want to thank you for attending the seminar. As a summary, just dynamic brakes are used for overhauling or braking your loads. Think about your environment, think about your location, think about how you're installing it. Think about your airflow. Airflow is very important. And remember that we're here to help if you need. I will just mention that you will receive an email with a link to a video of the presentation if you want to watch it later on, or someone else wants, one of your colleagues wants to watch it because they couldn't attend. You will also get a PDF version of the presentation. If you want to reply to us, let us know, we can send it to you. And you'll receive a certificate of participation, which some people need for continuing education credits. If you need a different format or if you need something else to be said on there, again, reply, let us know, and we can make something according to how you want it. All right, so we're going to go to the question answer session here.
Questions from the field. Question from Michael. Is there a spreadsheet or calculator available that would help to calculate resistor size?
So there are equations we can send to you. We have in sheets we use internally. One thing you have to remember is, you have to know your duty cycle. You have to know if it's overhauling or if it's braking. You have to know, your ambient temperature and those types of things. So there's a calculator. If you want, I can send you something. But most dynamic braking resistors are pre-designed for whatever your application is. If you have this horsepower motor and you know it's 20%, they're pre-designed. We'll have it already done for you.
Yeah, I think it's important to note that in addition to the drive manufacturers, for example, we showed in the quiz, most major drive manufacturers in the US, Danfoss, et cetera, there is a list of pre-designed braking resistors that have been vetted based on the published information from those manufacturers. So if you're looking for something quick and simple, those are readily available.
Yeah, and again, if their duties are 10% and 50%, you want something in the middle at 30%, you talk to somebody, or again, there's calculations I can send you, basic calculations to do to give you something, give you a rough estimate of where you need to be.
Question from Douglas. Are there any applications where you may want 100% duty cycle for the DBR?
Yes, there are. So that's a very good question. So the dynamic braking resistor duty cycle is assumed that after 2 minutes, typically the resistor elements will heat up to their maximum temperature. So if you are stopping in 2 minutes, if it takes you a full 2 minutes to stop that, that's going to be 100% braking cycle, cycle, even though it's only 2 minutes for every, 2 minutes per hour. You can't say that's only 2 minutes per 60 or 1/30th. You have to say it's a full 100%. So there are times when you have a large inertial load, for instance, as I discussed before, it takes a long time to stop. You're going to want that 100%. And there's also overhauling loads, like if you're lowering a crane, if it takes 2 minutes to lower that crane all the way down, again, that's going to be a full 100% load, 100% duty cycle.
We have a question from apparently a sad person in Columbus. How do you know which resistor style to use for a particular application?
So there are many different styles of resistors that we manufacture. Typically, one style is used for lower currents. The one that I showed before, that edge wound with those teeth, those are used for currents between, continuous currents between 15 and 80 amps. When you go above that, you use a grid style resistor. And the difference basically is the small wire wounds have a little piece of wire for very low currents. The more currents you have, you need more mass. Again, think of when you're installing something in your house, you need 20 amp wire. When you're installing something in your factory, you need 400 amp wire. It's a big, MCM, 500 MCM cable or whatever size it is, I don't know. So the more current you're going to have running through that, the more the different style resistor you're going to want. And typically, the resistor manufacturer knows what's best for the application as far as what current's running through it. Again, if you talk about something with a lot of vibration, they're going to use a certain style resistor for that also, right? So not just the current, but also the environment and what's going on may affect the design of resistor that they use.
And I tell you what, we're going to go one last question. I realize we've kept everyone a lot longer than the invite that listed this as a half-hour webinar. alluded to.
It did it really?
Are there standards that manufacturers use to make or to test dynamic braking resistors to regulate temperature?
To regulate. So there are no standards as far as as I spoke of before, the current running through that resistor heats up that resistor. There is no governing standard for the amount of temperature that you can rise that resistor, and when you figure out your wattage. So most manufacturers use about the same number. I can't attest to all of them as to what they use. They are going to be similar. Again, that is why I said before, you might have two exact same size resistors. One might say 1,000 watts, one might say 1,200 watts. They're probably the same resistor. It's just that the other manufacturer decided I'm going to let it run 100 degrees hotter before I put my wattage rating on there. So, but there is no governing standard that tells you what it has to be, unfortunately.
Thank you all for attending. Steve, thank you very much for the presentation. Again, if there's any questions, any follow-up, please feel free to email Steve, and we'll make sure we coordinate responses back to you.
Thank you very much for attending, and we hope to see you next month.